Okay, where we were before we were rudely interrupted. So, while the video was uploading, I went back and I calculated this number for you. I think it's 5.943 meters per second. And so that becomes the VF of below the window. So here you want your VI, you have your VF, you have your delta D, you have your A. The equation you would use would be VF squared is equal to VI squared plus 2A delta D. Rearrange it for VI. So VI squared will equal VF squared minus 2A delta D. Okay, and then fill your numbers in, and again, be careful of the negatives. So the VF, it's going up, and it's this 5.943, so 5.943 meters per second squared minus 2. A is still going down, so it still goes in as a negative 9.81 meters per second squared, and delta D for below the window is 4 meters. Okay, so square that VF that you have. You're going to end up adding the 2AD because of the negative, so 8 times 9.81, that's 78.8. And then remember, take the square root because that's VF squared. And so when you do, I think you get a VI squared. You get a VI of maybe 10.668 meters per second. And that would be upward. Okay? Alright, and the last one. This time the object is being dropped. Okay, an object is dropped from the roof of a school. It passes by the classroom window that is 4 meters below. Again, because it's up and down, I would do it this way. And so this will be above window. Okay, and it says that the window is 4 meters below, so delta D will be 4 meters. And it's down this time. It says that it's dropped, which means VI is 0. And A, of course, is 9.81 meters per second squared down. It takes 0.25 seconds to pass the lab window. So this is the window down here. And so the time to pass the window is 0.25 seconds. What is the height of the window? You're looking for delta D of the window. Again, A will be 9, be good if you could see that, 9.81 meters per second squared down. And again, what is it that connects the two sections? The VF this time, because it's going down, right? The VF above the window will become equal to the VI as you hit the window. Well, not hit the window, but pass the window. So this time, up here, you can find VF. And once you find VF, it becomes VI, and you can find delta D. So if you have VI, A, delta D, and you want VF, it would be VF squared is equal to VI squared plus 2A delta D. VI goes to 0. This time I don't have to worry about negatives because everything is going down, so everything, we can call it positive. So 2 times 9.81 times 4 will be VF squared, and then you will take the square root. So 8 times 9.81, I just did this a minute ago, and then take the square root, 8.859, let's say, meters per second. Keep all those numbers in your calculator, but you don't need to write them all down. So that becomes our new VI, and we're looking for delta D. So I have A, I have T, I have VI. I can just use delta D is equal to VI delta T, 1/2 A delta T squared. So delta D is equal to that 8.859 meters per second. The time is 0.25 seconds. Plus 1/2, 9.81 meters per second squared. And if you want to put a negative on that 9.81, you can. Just know that then you also have to put it on the velocity, because the velocity is also going down. Okay, so that looks really blurry. Can you make that out? And then this is going to be 0.25 seconds squared. And you will get your delta D. So the velocity that you have in your calculator that you didn't clear multiply it by 0.25, and then add 0.5 times 9.81 times 0.25 squared, and you should get 2.52. 2.5213 meters, etc. Okay? So that's it for that example. If I just go back, we were running out of time on the other video, so I didn't fill the numbers in. But if we filled our numbers in here, this would be 40 meters, 1/2. One car, first car was 4 meters per second squared, minus 1/2, 2 meters per second squared. So that's about 1 on the bottom. Oh, I think it's 40 meters, or 40 seconds squared, maybe. And then take the square root. And get 6.32. So delta t is going to equal 6.325 seconds. And then how far has each traveled? So now you take that and you fill it back into both of the delta d's. And once you do that, you'll know you got it right if they're 40 meters apart. And I think one's like 193 point something and the other's 153 point something. Okay? So now that you're really good at all of those, now you can go to this wonderful sheet and try them. And if you get stuck on one, just leave it and go on to the next one, because each one's a little different. So just because you can't do the first one doesn't mean you won't be able to do any of the rest. So if you get stuck on one, just leave it, go to the next one, try to set it up, get as far as you can on each of them, and tomorrow we'll go over them in class. Okay? Have a wonderful snow day. Happy shoveling. Happy physics. See you tomorrow.